এখানে কোশ্চেন দেওয়া আছে, it is given in our question that two particles A and B starts from the same point and move in the positive x direction in a time interval of 2 seconds after they start. Their velocities v varies with time as shown in the following figure. What is the maximum separation between the particles during their time interval? So as per our given question, the first particle, the graph of the first particle is this one. This one is the graph of the first particle. So if we consider about the graph about the first particle, then what we can say? Then we can say that, so this is our, this this is the pathway of the particle for the first particle, and this one is the, for the second particle, this is the graph. It is given or in our question. This is the path. Okay. Or this may or may not be included. This one may or may not be included. This one may or may not be included. Only this. You can take only this seesaw segment. Or you can say this one. There is dotted line, but this not including. Only the solid line is included. So from the, if we analyze our graph, the first particle, the starting when time t equal to 0. So this point is indicating our time t equal to 0, and here also the time t equal to 0. For the first particle, it is starting. What is the starting velocity? Its starting velocity is equal to 2, and it is going up to 1 second. Up to 1 second, the particle is moving in this path, and after 2 seconds, after 1 second, it is following, the graph is following this path. And for the second particle or particle B, the when time t equal to 0, the particle starts from the origin, and from this and as the time elapses, then it is moving in this way. So first of all, we have to discuss about the concept behind this question. So concept behind this question is, first we have to calculate the separation. Separation is the, as we know, in the velocity time graph, the separation is, what is separation? In the velocity time graph, what is separation? Separation is nothing but, separation equal to is area under, separation is area under V relative versus T, V relative versus T curve. Okay. And the second concept, we can, as a second concept, we can write the second concept is, separation need not be minimum or maximum every time. So what is the second concept? Our second concept is, separation need not be minimum or maximum every time V relative is 0. Okay. Or in our next concept, we can say separation need not be minimum or maximum. What? Separation need not be minimum or maximum every time v relative is 0. Okay. So first of all, from this two graph, we have to draw. So this is this first one graph. The first graph is representing the velocity versus time graph, and is second one is again velocity versus time graph for the particle B. So if we from this two diagram, if we combine this two diagram into a single diagram, then we can get the diagram for the relative velocity. So from this two diagram, first of all, we have to draw the relative velocity diagram for this two, for the two. So this is our time axis, and this is our velocity axis, which is VB minus VA. So VE minus VB minus VA is nothing but equal to V relative. It is the relative velocity. So if it is the relative velocity, so in our first graph, what we are seeing? In our first graph, what we are seeing? In our first graph, that at the it is in the first graph, it is a state segment. Velocity in the first graph is a state segment, and second is a seesaw line. So from this graph, we can say the resultant of these two, or if we minus this one, then we can get the resultant graph as this. The resultant of this for up to this segment means graph of this segment minus graph of this segment, and this resultant will be this segment, and its coordinates should be here equal to 2 unit. Here is 1 unit. Here is again 1 unit. And after that, so this time is indicating 1 second. After that, from during the time interval 1 to 2 seconds, again we have to find out the relative velocity. The relative velocity is something different, yes or no? So in the second part means in the part for the time interval from 1 to 2 seconds. So if we find the relative velocity, then their relative velocity must be equal to from this portion minus this portion. So again, this is identical but not the same, because in this first part, our straight line is velocity profile of the particle B is this one, and the velocity profile of the particle 1 is this one. If we subtract these two, then we can shift this graph. The total shift this graph by downward, that downward 2 unit, that this 2 unit direction is shifted in the downward direction. And in the second part, in the similar manner, we can say the here is separation is what? Here separation is 2 unit velocity. Here separation is 1 unit. So we can shift this graph in this much shifting. So this much, after shifting this one, we can further rewrite the drawing or the graph as this one. This is the repetition. So it is our complete graph. So this time is indicating what? So this time is indicating our time 2. Now what we have to find? We have to find the maximum separation between the particles during the time interval. So maximum separation is nothing but this is the area under the graph. So now, as we are seeing from our graph, this is the area of the graph, this one, and this is our area of the graph. So our maximum, so if we find the area of the graph, that is nothing but that is maximum separation. So we can say maximum separation equal to equal to half into 1 into 2. This is the area of this one, plus half into 0.5 into 1. This is the area of the second one, which is nothing but this will cancel out, and as a result, the first part is 1 and the second part is 0.25. So as a result, or as a net, we can say our maximum separation is equal to 1.25. So among the given options, first option is equal to 1 meter maximum separation. B is 1.25. Third option is what? 1.50. And in D part, the option is 2 meters. So our answer, as per our calculated answer, the calculated answer is 1.25. So right answer, we can say the right answer is equal to 1.25 meter. So here the question is solved now.